by this time, you're probably pretty good at thinking in binary. You might even have the place values memorized for an 8-bit binary sequence. 128, 64, 32, yada yada. Well, good. But is there another way to think about all of this? We haven't programmed for a while, so let's see how we can combine the programming you learned in Unit 2 with your newly acquired knowledge of the binary system. You are going to be tasked with trying to get birthday candles to light up, quote unquote, on a cake to represent an age of a person in binary. So the candle is on, that represents a 1, the candle is off, that represents a 0. So I'm sure you probably already have some ideas on where this is going, but before you get started on, let's just review some of the important concepts that you will probably need to use for this exercise. All right, so first of all, it's been mentioned before that we can do something called modular arithmetic, that we can actually do division and not worry about what the answer is, but worry about what the remainder is for that answer. Okay, so for example, if I had, the number 20, and I wanted to do 20 mod 3. Okay, so that would be, if I took 20 and I divided it by 3, first of all, what would be the answer? Well, the answer, 20 divided by 3, 3 can go in up to 6 times for 18, but there's a remainder of 2. Okay, so I'm just going to write that kind of over here. So 6 times 3 equals 18, right? So 20 divided by 3 would equal 6. Remainder, remember that? It's been a long time since you had to write a remainder, right? Remainder 2. Because 6 times 3 is 18, plus 2 more is 20. Okay, so the answer to 20 mod 3 is 2. Okay, when you finished long division in 6th or 7th grade, you kind of didn't worry about the remainder anymore. Or if you had a remainder, you had to carry it out into decimal form. But just as a review of that, with modular arithmetic, you have the ability to kind of ignore the answer and just stop when you have a remainder, and you can no longer take groups of that number out and just end up with that. Okay, so that's an important thing that I want to point out. And Scratch does give you the ability to use the mod operator. Next thing we want to talk about is the concept of strings, okay? And remember that strings, and I put those in quotation marks because a lot of times when we refer to strings in text-based programming, they are placed in quotes so that the computer knows, listen, don't treat this like a number, because remember, everything is a number to the computer. Don't treat this like a number, just treat it like a bunch of keyboard characters, a bunch of ASCII characters or Unicode characters, now that you know those terms, and just put them together. And remember, we can do a little something called joining or concatenating, but in Scratch you use the word join. We can concatenate keyboard characters together to make strings. Okay, and again, the computer treats those as just text, not a number. Okay? The third thing we want to take a second to go over are variables. The important thing about variables for this lesson is to remember that variables will vary. They will change. That's where the name comes from. Sometimes when we, for example, when we ask our user for input, we want that input to persist in our program, but we also need to work or process that input, meaning it's going to change. So variables provide a way for us to hold on to values and to also create new values. All right, so remember the concept of variables because we haven't used those in a while. All right, now I'm going to bring up the big word that we use when we're talking about binary, dichotomous. Okay, and we said that's like there's two possibilities. It's either this or that. It's either on or off. It's 1 or it's 0. It's true or it's false. It's yes or it's no. All right, well, the particular dichotomous relationship we're going to talk about now is the fact that numbers can be either odd or even. There is no other choice. They are either divisible by 2 or they are not divisible by 2. Okay, so they're odd or they're even. So that's something to remember about numbers. Okay, and finally, just so you don't forget, because this is also important for this exercise, remember the 3 logical structures that we have been talking about since we started programming. We've talked about sequence, selection, and iteration. when we use sequence, the order is important. Okay, the order matters. Well, not always, but it can. The order can be very important. When we use selection, we choose one path, knowing that that path may never join up to the other path. All right, and then iteration means using repetition. All right, so just remember those three things because they're all going to come together in this exercise. All right, so hopefully you have opened the starter code for the exercise and you're looking at it and seeing fancy looking things, a few things that are already set up for you that may or may not be correct. So I want to review with you the way that we've been talking about binary. First of all, remember that a binary sequence, and in this case, you only need to have 7 digits. You don't need the full 8 digits because I'm not remembering the name of the fabulous person that is mentioned in the exercise, but until modern medicine takes another miracle turn, we don't need to represent numbers up to 128. All right, so I just want to remind you again of how that looks. So that gives us, here's our blanks. All right, here's our blank for 2 to the 0 power, or 1. Here's our blank for 2 to the first power, or 2. Here's our blank for 2 to the second power, or 4. Here's our blank for 2 to the third power, or 8. Please don't let me run out of room. It's going to get a little cramped here. 2 to the fourth power, or 16. 2 to the fifth power, or 32. All right, 1, 2, 3, 4, 5, 6. All right, we're just going to squeeze this guy in here. 2 to the sixth power, or 64. All right, and remember, we can create the numbers up to 127 with these. All right, so let's say our birthday girl is turning 18. She is going to be able to vote. So this is a momentous occasion. So we want her birthday cake to light up the right way. Right, so the way that we've talked about it so far, we would say, how many groups of 64 can I make with 18? 0. How many groups of 32 can I make with 18? 0. How many groups of 16 can I make with 18? 1. Okay, and hopefully we can, I can make the intuitive leap to just jump over here. 16 plus 2 gives us 18, and I'm just going to fill in the rest with zeros. Okay, so I know that I need, the way that they do this, let's see, this is the violet, this is indigo, this is blue. I only know this because of Roy G. Biv. Let's see, this is the green, this is the yellow, and then I think it goes orange and I think it goes red, right? Roy G. Biv. Okay, all right, so I know that I need yellow and indigo. Do you even know what color indigo is? I think the guy who made the scratch thing does, because I would guess that's indigo. All right, so I need the yellow and the indigo to light up to show 18. All right, so really, I could make a very mathematical algorithm that checks to see, here's my original number. It's getting lost in all my notes here. My 18, I could check to see, is 18 greater than 64? If yes, you know, something. All right, is it greater than 32? Is it greater than 16? All right, is it greater than 8? So I could do something with that, a typical mathematical type of algorithm. Thank goodness I'm about to erase this mess here. But let's think about this a little bit differently. By the way, you should know how to do this. Okay, this whole conversion of decimal to binary. Make sure you have that down. But let's talk a little bit about another way to think about this, okay? Because that's the thing with algorithmic thinking. Yes, there is, one particular way that we can do things, but there is always another. And in this case, there does happen to be another really good way. And it goes back to what we learned from watching The Amazing Binary. Let's stick with our answer of 18, of our person turning 18 for their birthday cake. To do that, I'm going to go ahead and I'm going to track that number. I'm just going to put that number up here. All right, number 18. And I'm going to think about this in terms of the candles. All right, so I'm going to go down here, down towards the bottom, and I'm going to give my different candles. Now, I'm not going to try to find the red, orange, yellow, green, blue, indigo, violet pens, but I did pretty well finding purple here, right? So here's the indigo candle, or 2 to the 0. No, that was the violet candle. This is the indigo candle, or 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th. All right, so those are our candles. Okay, so 0, 2, 4, 8, 16, 32, 64. And we don't need any more than that because we're not going over 127. All right, so in the Amazing Binary, you saw something interesting. You saw the number that they started with was cut in half. First, they would tell you something like, I can't remember how that delightful little wizard phrased it, something about how there's no remainder. Okay, well, maybe something like this what's going on. Okay, now 18 mod 2 is 0. Okay, so I'm going to go ahead and take a chance, and down here I'm going to say, well, maybe that meant that this candle right here was 0. Okay, and then what it looked like was happening was that 18 divided by 2 would give me 9, and it looked like the number 9 was red, or would have been red, because it looked like odd numbers were red. Okay, so I'm just going to put that in red. And then let me switch to green. All right, so 9 mod 2 gives me 1, right? Okay, so maybe that means that 9 mod 2 being 1 means that I should go down here and put a 1. All right, and then remember, it looked like they took that number and divided it by 2. Well, now we have a little bit of a problem because 9 divided by 2 gives me 4.5, which is a decimal. But I never saw a decimal in the Amazing Binary. So it seems like the Amazing Binary was actually maybe rounding down. Okay, so 4.5 rounded down would give me 4. All right, and 4 is even. Come on, catch up with me, pen. Yeah, if you can decrypt that, good luck. So 4 mod 2 is equal to 0, meaning that it is an even number. 4 is even, because it can only be one or the other. All right, so I'm going to fill in a 0 there. All right, and then again, what it seemed like was going on was that 4 was being cut in half. Okay, so here's the next one. 2 mod 2 also equals 0. Okay, nicely enough. Okay, so let me go down here, replace that with the 0. All right, and then I'm getting to like this math. This math is getting a lot better for me. Half of 2 is 1. Okay, and 1 mod 2 gives me just 1. It goes in 0 times with a remainder of 1. In other words, it doesn't go in at all. All right, so I'm going to fill in my last 1 here. 1. All right, so it looks like the red and orange candles would be out. Red, orange, yellow would be on. Green, blue would be off. Indigo would be on. Violet would be off. So let's see, would that even work? Let's find out. Okay, so we said this is 2 to the 0 power, or 1. This is 2 to the 1st power, or 2. This is 2 to the 2nd power, or 4. 2 to the 3rd power, or 8. And 2 to the 4th power, or 16. So I've got 16 plus 2 indeed gives me 18. All right, so this is an interesting algorithm. So really what was going on was my binary age down here. I'm going to tell you this. It started off as an empty string or a blank space, okay? And I treated it as a string from there on out because I just added a 0 and then I added the next indication of whether it was odd or even. And I just continued to join each of those characters until it created this string right here. Okay, we know this is the binary representation of 18. It absolutely is. But in this particular case, the way we obtained it was as a string. Okay, so this is kind of an interesting algorithm that might lead you better towards a solution for this birthday cake problem. And fortunately for everyone, here we go, erasing that. give it your best try on this scratch exercise. You can really do some interesting things. I will tell you one thing, that if you stick with this algorithm, sequence is going to be extremely important, because the sequence with which you light the candles is going to be important. All right. It might seem like there's a lot of repetitive code, which would normally be a red flag that refactoring would be in order, that you would want to maybe use some sort of repeat until loop, like repeat until the remainder or the half that you're working with is 0. And normally that would be good. But again, unfortunately, each candle needs to be treated in sequence. If you're absolutely stuck, let me just throw this out there. All right, this might be an interesting block of code for you to think about. Just to set it up for you, when we're talking about variables, you definitely want the decimal age to stay on the screen, and it's set up to do that. But it needs to change, because remember, we need to cut the remainder in half every time. So you may want to also have a remainder or a temp type of variable that would hold that remaining half, all right, to determine whether or not it is. All right, here's the join that I was talking about. We actually haven't visited broadcasts in a long time, but remember, if you want to send or throw the action of the script to another sprite, broadcast is how you do it. And remember that that sprite will have a script that starts with that little hat-shaped deal, and it'll say, when I receive this broadcast right here, and then this is going to be a costume change. All right, and each of the candles will need to have a script that tells it what to do when it receives its change script. So these are just some hints for you, but I think that with all of this help, I think that you'll be able to get this program working in no time. Have fun.